Hello, mathematicians. Let's review two very important terms, multiples and factors. And it's easy to get these two terms confused, but as thoughtful, careful mathematicians, I have no doubt you will master these definitions. So remember, a multiple, say it with me, a multiple is the product of a given whole number and another whole number. So here's an example. If we wanted to get multiples of 6, we would say 6, then 12, then 18, 24, 30, 36, and so on. What do you notice about the multiples? You may be saying, well, this is 6 times 1, 6 times 2, 6 times 3, 6 times 4, right? Obviously, because that's the definition of a multiple. You might also be noticing that they're skip counting by 6. We're adding a group of 6 each time because that's what multiplication is, adding another group. So you would see multiples if you look on, for instance, your multiplication chart, all those solutions, those products are your multiples. Now, factors, on the other hand, are the numbers being multiplied. You can find all the factors of a given number using the rainbow method. So when you hear factors, think rainbow method. When you hear factors, what do you think? Rainbow method. You got it. And today I was saying it could almost be called the smiley face method because in this case I only left myself room on the bottom. So I'm going to do this, right? If I had factors of 12, I say, well, is 1 a factor? Yes. 1 times 12. See my little smiley face? Is 2 a factor? Yeah, 2 times 6. And is 3 a factor of 12? Yeah, 3 times 4. Is 4 a factor? We say, yeah, we already had it. Have a catchy little jingle for that. We say, we made it back to the turnaround fact, right? We knew 3 times 4, and then we got back to 4 times 3. So let's practice this. And once we practice it together, you're going to get a chance to practice these same skills, the same vocabulary on HomeLink number 3 for the mid-year assessment. It says list the first 5 multiples of 5 and then list the factors of 15. I want you to pause the video and try problems 1 and 2 on your own. Play back and when you're ready to hear the answers, make sure you pay attention to the vocab. Okay, welcome back. So your multiples should have been 5, 10, 15, 20, and it wants 5 of them, so we go up to 25, 5 times 5. But then your factors of 15 are going to be 1 and 15. 2 is not a factor because it's an odd number. 3 and 5. 4 is not a factor because, again, odd number. And then 5, but we already have it. We made it back to the turnaround fact. Now, I love this question number 3. It says, is 15 a multiple of all the numbers you listed in problem number 2? So is 15 a multiple of 1, 3, 5, and 15? What do you think? Yes, yes, it is. Of course, because those were the factors. So we already know that is 15 a multiple of 3? That means can something times 3, some whole number times 3 equal 15? Yeah, because we just said that 3 times 5 equals 15. So a kind of a rule you can apply for yourself is to know that any so it's 15 a multiple of any, how do I want to phrase this? A number is always a multiple of its factors, is what we could say, right? Because 15 is going to be a multiple of all the factors of 15. So I'm going to write that down for you. A number, say it with me after I write it. A number is always a multiple of its factors. Okay, let's say that together. 1, 2, 3. A number is always a multiple of its factors, just by definition. Okay, last 2. I want you to pause the video and try problems 4 and 5 on your own. Play back when you're ready to see the answers. So 24, you probably noticed, has a lot of factors. We have 1 and 24. Is 2 a factor? Yep. 2 and 12. Is 3 a factor? Yes. 3 and 8. Is 4 a factor? Yes. 4 and 6. Is 5 a factor? No. Is 6 a factor? Yes, but we already have it. We made it back to the turnaround fact. So these should be all your factors of 24. And the final question, is 24 prime or composite? You should have said it is composite. And how do you know? Well, a prime number's only factors are 1 in itself. A composite number has more than 2 factors. So you just proved in problem number 4 that we can say because it has more than 2 factors. And in fact, in problem number 4, you see that there are many more than 2 factors. And again, we want in our explanation to use some good math vocabulary.